In today's class, let us discuss about interpolation. If y0, y1, y2, so on, yn be the set of values of an unknown function y is equal to f of x corresponding to the values of x, that is x0, x1, x2, so on, xn, then the process of finding the value of y for any given value of x between x0 and xn is called interpolation. The process of finding the value of y outside the given range of x is called extrapolation. But in general, the concept of interpolation includes extrapolation also. The next is interpolation formula for equal intervals. So here we have two cases again. One is forward interpolation formula and another one is backward interpolation formula. It is given by Newton. So it is called Newton's forward interpolation formula and Newton's backward interpolation formula. And it is given by yp is equal to y0 plus p into del y0 plus p into p minus 1 by 2 factorial into del square y0 plus p into p minus 1 into p minus 2 divided by 3 factorial into del cube y0 plus continues so on plus the nth term is p into p minus 1 into p minus 2 into so on p minus n minus 1 divided by n factorial into del power n y0. And here this p, you can see some p's here. See, this p refers that x minus x0 divided by h. This x is the point at which we have to find the value of y, x0 is the initial value of x, h is the step length or the common interval. Now let us see what is backward interpolation formula. This is a backward interpolation formula, that is Newton's backward interpolation formula, and it is yq is equal to yn plus q into nabla yn plus q into q plus 1 by 2 factorial into nabla square yn plus q into q plus 1 into q plus 2 divided by 3 factorial into nabla cube yn plus so on continues plus the nth term is q into q plus 1 into q plus 2 into q plus 2 into so on q plus n minus 1 divided by n factorial into nabla power n yn. Here these q's, here you can see some q's here, right? Those q that q refers x minus xn divided by h. X is the point at which we are finding the value of y and xn is the final value of x, h is the step length or the common interval. Now I'll tell you what are the difference we can remember while using these formulas in solving the problem. See, in the forward interpolation formula we used to have this p value. In backward interpolation formula we used to have this q value. See, this p is nothing but x minus x0 divided by h, q is nothing but x minus xn divided by h. So in backward we used to have this xn, in forward we used to have this x0. In forward we are using initial value, in backward we are using final value. There is a one difference. And another difference is here in all the terms we are using del y0, del square y0, del cube y0, so on del power n y0. So the leading forward differences we are using in this formula. And here if you see nabla yn, nabla square yn, nabla cube yn, so on nabla power n yn. See, these are the leading backward differences. You can see this, you can see these things when you construct the difference table. This is the second difference we have. And one more difference is there, that is here in the forward interpolation formula we used to have this minus here. In all the terms we can see minus here. See, p into p minus 1 by 2 factorial, p into p minus 1 into p minus 2 divided by 3 factorial. Likewise you can see minus here, negative. Here it is positive. q into q plus 1 by 2 factorial, q into q plus 1 into q plus 2 divided by 3 factorial, so on. See, all the terms are positive here. Here all the terms are negative. So these are the three important things you have to keep it in your mind while writing the formula. Now we have note here. In order to estimate the value of y at a desired value of x near the beginning of the table, we use forward interpolation formula. Similarly, near the ending of the table, we use backward interpolation formula. And if it is lying in the middle of the table, we can use any of the forward or backward interpolation formula. This will be understood while solving the problem. Anyway, we'll have an example. This is the first example I have. Find y of 1.4 given in the data. Given the data, x values are given, y values are given. See, x values are given 1, 2, 3, 4, 5. See, what is the difference you can see. See, here we are discussing about common interval. See, interpolation formula for equal intervals. So here the interval length of the interval is 1. When you take the difference, you can get the length of the interval, that is length of the interval is 1. Here from 2 to 3, 1. From 3 to 4, the difference is 1. From 4 to 5, the difference is 1. So the difference is equal. So when you have these kind of things, so we can use forward or backward interpolation formula according to the problem. Now let us see where this 1.4 lies. This 1.4 lies in the first half of the table or near to the initial value. What they are telling, near the beginning of the table. If the point at which we have to find the value of y is lying in the near the beginning value, we have to use forward interpolation formula. Or if it is lying in the first half of the table, this is the first half of the table, this is the second half of the table. In the first half of the table, if it is lying from here to here, if it is lying, then we have to use forward interpolation formula. If suppose the value you have to find that is lying in the second half of the table from here to here, if it is lying from 3.3 to 5, wherever it is lying in between 3 to 5, then you can use backward interpolation formula. Okay, now let us see how to solve this problem. See, since it is lying in the first half of the table, we have to use forward interpolation formula. According to forward interpolation formula, there is a formula. So we have to construct the forward difference table. So in the last video I have explained how to construct the forward difference table. As I explained earlier, difference table is same. We have to have the denotions change. It will be depending according to the forward or the backward. See, if it is forward, then we used to have this numbers. We used to identify these numbers as leading forward differences. For the same difference table, if you want to construct the backward difference table, we will be identifying these as the leading backward differences. Since we are using forward interpolation formula, we have to identify these terms. I have explained these things in the last video. So you have to construct the difference table. By to construct the difference table, take the x values and take the y values. This is the difference for the first one. Since it is forward, it is del y, and the second one del square y. For the third one, del cube y, del power 4 y. Continues it. It will be continuous. Continued. Here, you know how to find the difference of this. 26 minus 10, 58 minus 32. Sorry, 58 minus 26 is 32. 112 minus 58 is 54. 194 minus 112 is 82. Similarly, the difference of this 32 minus 16, 54 minus 32 is 22. 82 minus 54 is 28. Similarly, 22 minus 16 is 6. 28 minus 26 is 6. Then again 6 minus 6 is 0. So we have got the nth value also, that is del power 4 y naught is 0. Del cube y naught is 6. Del square y naught is 16. Del y naught is 16. Now let us substitute all these values in the formula. What the formula is telling? This is the formula. So let us have the formula here. Let us have the formula here. See, this is a problem, there is a table, and for this one we have the formula. There is a Newton's forward interpolation formula. For this formula, we have to identify these terms. So we have identified these terms. These terms we have to identify. Yes, we have identified in the table. Now we have to find this p value. How to find the p value? I told you p value is nothing but x minus x naught divided by h. X is the point at which we have to find the value of y. So y at 1.4 they are asking. So y at x is 1.4. X is 1.4. X naught is the initial value of x. What is the initial value? X naught, x1, x2, x3, x4. So x naught is 1. X naught value is 1, and the step length or the common interval is h. What is the step length or the common interval from 1 to 2, 2 to 3, 3 to 4, 4 to 5? The step length is 1. That is h is 1. So when you simplify this, you will get 0.4. Now let us substitute all these values, that is p value and these values from the table. Substitute in this formula. That is yp is equal to y naught. Y naught is the initial value of y, that is 10. 10 plus p value is 0.4 into del y naught. What is del y naught? Del y naught is 16 from the table. 16 plus p into p minus 1 by 2 factorial. P is nothing but 0.4. 0.4 into 0.4 minus 1 by 2 factorial into del square y naught. Del square y naught is again from the table 16 plus p into p minus 1 into p minus 2 divided by 3 factorial, that is 0.4 into 0.4 minus 1 into 0.4 minus 2 divided by 3 factorial into del cube y naught. Del cube y naught again from the table, it is 6. It is 6 plus, again since the last term is 0, since the fourth term is 0, I have not written the term, anyway it will be 0. Now when you simplify these terms by using calculator, you will get 14.864. Now let us see the second problem. The second problem is the following table gives the value of tan x for x lies between 0.10 to 0.30. See, x lying between 0.10 to 0.30. We have to find the value of tan at 0.26. Now let us see, this is a given table, this is a given data. See, x values are given and y values are given, that is tan x values are given. See, when x is 0.10, tan of x is 0.1003. When x is 0.15, the tan of this is this. Similarly, when x is 0.20, the tan of 0.20 is this. Similarly, these values are given. Now they are asking us to find tan of 0.26. Okay, where this 0.26 will lie, let us search. See, here 0.25, then after 0.25, 0.26 will come. So it is lying in between this interval. So it is lying in the second half of the table. See, this is the second half of the table. This is the first half of the table. From here to here it is first half of the table. From here to here it is the second half of the table. In the second half of the table, since it is lying, we have to use backward interpolation formula. We have to use Newton's backward interpolation formula. See, for the backward interpolation formula, this is a backward interpolation formula. Since we are using backward interpolation formula, we have to construct backward difference table. See, for the backward difference table, anyway, x values are same, y values, that is tan x values, or whatever it is given in the problem, it is written as it is. Now, since it is backward again, nabla y, nabla square y, second difference, third difference, nabla cube y, fourth difference, nabla power 4 y. So, these are all we can find by taking the difference of these entries and these entries and these entries and so on. So, you can get these values, it is not a matter. Now, let us find q value. Since we have to substitute q value here, let us find q value. What is q value? Q is nothing but x minus xn divided by h. X is the point at which we have to find the value of y. That is tan of 0.26 we have to find. So x is nothing but 0.26. At this point we have to find the value of y. So it is 0.26 minus xn. What is the value of xn? Xn is the last value. Which is the last value of x? That is 0.30. So minus 0.30 divided by h value. What is the value of h? H is the common interval or the step length. From here to here, what is the step length? 0.10 to 0.15. What is the step length? When you take the difference, you will get that is 0.05. Anyway, the difference will be same for all the intervals since it is equal intervals. So you will get 0.05. When you simplify this, you will get minus 0.8. The q value is minus 0.8. Now when you substitute this q value in this Newton's backward interpolation formula, you will get these terms. I will write the terms carefully. I'll tell the terms carefully. Yn is nothing but 0. The last value of this y, that is 0.3093. 3093 plus q value is minus 0.8. Nabla yn. Nabla yn is, I told you, since it is backward difference table, these are leading backward differences. These values we have to use in the formula. See, Nabla yn. Nabla yn is 0.0540. 0.0540 plus q into q plus 1. 0.8 into minus 0.8 into minus 0.8 plus 1 divided by 2 factorial into Nabla square yn. Nabla square yn is 0.0014 divided by 2 factorial plus q into q plus 1 into q plus 2 divided by 3 factorial, that is minus 0.8 into minus 0.8 plus 1 minus 0.8 plus 2 divided by 3 factorial into Nabla cube yn. What is Nabla cube yn? 0.0004. 0.0004 plus again q into q plus 1 into q plus 2 into q plus 3 divided by 4 factorial, that is minus 0.8 into minus 0.8 plus 1 minus 0.8 plus 2 minus 0.8 plus 3 divided by 4 factorial into Nabla per 4 into y. Nabla per 4 yn. Nabla per 4 yn is from the table again 0.0002. So this is the value we substituted. Now simplify this by using calculator. You will get f of 0.26, that is 0.26602. It is nothing but tan of 0.26 is 0.26602.